Hello everyone, this is Mr. Appel, and today I'm going to show you how to solve log equations and be aware of extraneous solutions. So you see this log equation is a little more complicated than some of the others that we've seen. The same strategy applies. We want to get the logs all together in one log so that we can rewrite it as an exponential. And as you're going to see, once we do that, something interesting will happen. So first, let me get all those logs together on one side. So I'm going to have that log of x plus 4 minus log of x minus log of x plus 2 equals 0. And now we're going to use our rules of logs here to rewrite this all as one log. So this is from our earlier work with logarithms. If it helps you to think of, since these are both minus, have that whole thing be minus and then distribute so that it's basically, let me change colors here, so it's the log of this minus that, so that we can change this part to log of x squared plus 2x, right, because we're multiplying together. So this becomes log of x plus 4 minus log of x squared plus 2x equals 0. And now I can, since when we subtract, we divide. So log of x plus 4 on the top and x squared plus 2x on the bottom equals 0. So just did what we know about manipulating logs, condensing, right? Condensing all three of those logs into one log expression. And now you see why we learned how to do that, why we did that work earlier. Because now we can actually rewrite this in exponential form. This is base 10, so if we rewrite this as an exponential, that's 10 to the 0 equals this. Well, 10 to the 0 is 1, so really what we have is x plus 4 over x squared plus 2x equals 10 to the 0 power, which is 1. And now we have kind of a funky looking equation, but one that we can actually solve fairly easily. I use that term loosely. It's not super easy, but you know how to do it. So we're going to multiply, but we're going to clear out the fraction. So we're going to multiply both sides of this equation by x squared plus 2x. So we have x plus 4 on the left and x squared plus 2x times 1, which of course is just x squared plus 2x on the right. Okay, so now we got the logs out of the picture, but now we actually are left with a quadratic. So we've got a little more work to do. So I'm going to put that quadratic in standard form. I'm going to subtract the x and subtract the 4 to set it equal to 0. So that becomes x squared plus x minus 4 equals 0. And now we have a quadratic equation in standard form. It's not factorable, so we're going to have to do quadratic formula or completing the square. I'm going to complete the square just because. So I'm going to move that 4 over. B is 1 here, so b over 2 squared. Remember, b over 2 squared. In this case, that's 1/4. So I'm going to add 1/4 to both sides. If you prefer to do quadratic formula here, you can. I just tend to like completing the square. So the square becomes, oops, that's a little hard to read. The square becomes, remember, whatever that was. So it's x plus a half on the left squared, and on the right I'm going to get a common denominator, so that's 16/4 plus 1/4 is 17/4. Okay, and now we can take the square root of both sides. We have x plus a half equals the square root of 17 on the top. Square root of 4 is 2. Don't forget your plus or minus. And so we get x equals, let's subtract, so that's negative 1/2 plus or minus square root of, whoa, what was that? Let's try that again. It's negative 1/2 plus or minus square root of 17 all over 2. So now we have two possible solutions. Common denominator there, so we have either x equals negative 1 plus rad 17 over 2, or negative 1 minus rad 17 over 2. But here's where it gets even more interesting, as if it wasn't already interesting enough. This expression over here on the left, this first one, is a positive number. Square root of 17 is a little more than 4, so negative 1 plus a little more than 4 is positive, so no problem there. But this expression over here, negative 1 minus rad 17, is clearly negative, and we can't have a negative solution because we'd have a log of a negative, and as you know, the domain of log functions, the thing you're taking the log of, has to be greater than 0. So this is an extraneous solution. It does not actually solve our equation, so we have to reject it, and we're left with just this equation here. And that is one example of solving a log equation with extraneous solutions. Now let's take a look at another example. Here we go. If you want to go ahead and try this one on your own, you can. This one's actually a little bit easier. I probably should have started with this one. So this one, we're going to, again, combine the logs together, condense them together. We've got adding of logs, means it's the log of the product. Ooh, I'm still in blue. I like that blue, so we'll stick with it. So it's the log of the product, so that's x squared minus 15x. Now that it's a single log, we can rewrite it in exponential form. Base is 10, so that's 10 squared is equal to x squared minus 15x. And again, we're left with a quadratic that we know how to solve. So let's go ahead and set it equal to 0. So we have x squared minus 15x minus 100 equals 0. And here we have a quadratic that is actually factorable, so we like that. Pretty easily factorial this one, x minus 20 and x plus 5. So we get our two possible solutions, x equals 20 or x equals negative 5. If you plug 20 back in there, no problem, because log of 20 is something and log of 5 is something. Right? If you plug that 20 back in there, no problem. We don't get any logs of a negative, so that works. But if you plug in negative 5, no good. Can't have a negative x value. Can't take a log of a negative number. Both of those would blow up in this case. So again, we have an extraneous solution. That doesn't work. We have to throw it out. That's all for now. Thanks.